Yes, tell me. Any doubt?
Sir, I had a doubt, sir.
Yes.
Sir, in the previous class, for the standing wave, we took the incident wave as a sine omega t minus kx, and for the reflecting wave, we took the minus of that. So I didn't understand why we did that. Even though the phase was different, we took the negative.
No,
Of
just 1 minute. Suppose if you have a wave which is going along this direction, let's say this particular direction to be positive x-axis and opposite to it will be negative x-axis. So y incident will be a times sine omega t minus of kx. Is it clear?
yes, sir.
But on reflection, the reflected wave will be just opposite of it, since the endpoint connected to this particular string is rigid, so it will reverse the direction. So reflected will be this part. Now, if you proceed this wave backward, you get same direction of projection. So projection on this particular graph or curve and projection on this particular curve, both are in same direction. So difference between these two adjacent points will be pi. That's why we can say phase difference between these two waves will be pi. Is it clear?
What is sir? Sir, and also the
Just 1 minute. So y reflected in this part will be a times sine. This reflected wave is going towards which direction? Positive x-axis or negative x-axis? Negative x-axis. So we may write it as plus of kx. And since this particular wave is differ in phase to the incident wave by pi, so we may write it as pi. So in place of this pi, since according to the formula sine pi plus theta, it would lie in third quadrant where sine theta will be negative. That's why it will be minus of sine theta. So we may write it as a times sine omega t plus kx like this. Is it clear?
Yes, sir. Sir, also the particle velocity equation is just lambda by t, right?
In particle velocity, we had y equals to a times sine omega t minus of kx. So on differentiating this part with respect to time, you will get omega times a cos omega t minus of kx. This will define you nothing but particle velocity.
So, but that is the traveling wave velocity, right?
Yeah.
So, what is the difference between that and particle velocity? Particle is
in this part, we have particle, which is just 1 minute. Suppose this is disturbance created by particle at any instant of time, let's say t1 second. So at this point, particle will be these different points, which will be oscillating up and down like this. But all of a sudden, since this entire disturbance may also propagate with respect to horizontal, so it gets shifted towards the right side with some velocity, which is called velocity of wave. So this particle will have both vibration about up and down, and also this entire term gets shifted towards the right. That's why we have two different parts in this expression also.
okay. So the first one is particle velocity, second one is wave velocity.
Yeah.
Okay. And wave velocity is just frequency and amplitude.
Wave velocity is equals to lambda divided by time period or lambda times frequency or omega by k. You may calculate using these different formula.
Understood, sir. Got it.
Any more doubt?
No, sir.
Sir, could you please explain that node and antinode part again?
Okay. Suppose a wave is propagated along this direction. On getting reflected back, this will be reflected. So we have two different points. First, this point of minimum amplitude. This is called node. The next one, this point of maximum amplitude, which is called antinode. So on superposition, according to the equation of a standing wave, you will get y equals to 2 times of a sine of kx and cos of omega t. So in this part, this term will define you nothing but vibration of particle about their mean position are up and down, up and down. And this part, no particle will be going to and fro, to and fro. They just only oscillate up and down, creating these type of structure. So this part will define you their position. So on the basis of its maximum value and minimum value, we may define two different points. One is called node and one is called antinode. Node for which sine of kx become minimum. So sine of kx minimum will be 0. So general formula for sine to be 0 will be n pi. So kx will be n pi, or x is equals to n pi by k, or if you put k is equals to 2 pi by lambda, you will get n lambda by 2. Now put n to be 0, 1, 2, 3, so on. So position of node will be 0, lambda by 2, 2 lambda by 2, 3 lambda by 2, and so on. There was a question in assignment. You have to calculate, find distance between two adjacent node. Let's say this is one of the node and this is adjacent node to it. So what would be the distance between these two nodes? Just subtract these two parts. You'll get lambda by 2. So from distance between two adjacent node will be lambda by 2. Similarly, we may define antinode at which sine of kx will be maximum. So maximum value of sine will be for 2n minus 1, you may say, or plus 1, depending upon what you are taking for the value of n. If I'm taking n to be 0, so it will be plus 1 times pi by 2. So x will be 2n plus 1 pi by 2 times of k, or simply 2n plus 1 lambda by 4. Now substitute n from 0. So position of antinode will be lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. So again, if you will be asked to calculate distance between two adjacent antinode, so first part we have lambda by 4, second part we have 3 lambda by 4. On subtracting, you will get 2 lambda by 4. That is nothing but lambda by 2. So distance between two adjacent antinode will be again lambda by 2. Is it clear?
Yes, sir.
So why are we equating kx to n pi?
To get generalized value for any different expression.
Yes, sir. Yes, sir. Since sine pi is 0, that's why pi came, right?
Yeah.
Okay.
There was a question, test paper, you have to calculate number of node and antinode according to the given sample. Suppose if you have to calculate number of node and antinode in this part, what you will say? How many node and antinode are there in this part?
So 4.
4 node and 3 antinode, like this. Okay, any more doubt from this entire wave chapter? Minashi?
No, sir.
Let me define a question related to this part. There will be a question. Find ratio of VRMS and velocity of sound. I define you this part. Velocity RMS for gas will be 3p by rho root under, and velocity of sound according to Laplace correction will be gamma times p by rho. Just divide these two terms, you will get VRMS divided by velocity of sound, it will be just 3 by gamma root under. Next question will be, why transverse wave can travel through solids only, but longitudinal wave can travel through all medium. I define your reason of this particular part. Raza, any idea? Why transverse wave can travel through solid only, but longitudinal wave can travel through all different medium? Gautam?
So should we give mathematical explanation? What kind of explanation should we give?
I define you for transverse wave, we had velocity is equals to Young's modulus divided by density times strain. So we can say this velocity depends upon y, that is Young's modulus. And for which matter we may define Young's modulus, for all different medium or only for solids?
For solids.
So we can say transverse wave can travel only through solid. So I define you, since transverse wave depend upon elasticity and shape of that particular object or body or medium, and elasticity in shape is defined only for solids. That's why transverse wave can travel only through solids. But in case of bulk mode longitudinal wave, velocity is equals to root under beta by rho. It means longitudinal wave depends upon beta, bulk modulus or compressibility, which is defined for all different medium. Hence, it can travel through all different medium.
Sir,
Yes,
sir, but light is transverse wave, right? It can travel through all medium.
we are discussing only about mechanical wave.
Oh, okay.
Light is a type of transverse wave in which electric field and magnetic field oscillate perpendicular to the direction of propagation of wave. Next, there will be a long question related to this part. To define longitudinal wave, derive velocity depending upon beta and rho, define Newton's relation or Newton's assumption, hence Laplace correction to it. So for long answer, you will be asked this entire part. Is it clear?
Yes, sir.
Yes, sir.
Also, there will be a question on traveling wave. You will be given just one equation, and on the basis of which you will be asked to calculate 5 or 6 different segments like amplitude, wavelength, direction of propagation, frequency, velocity of wave, velocity of particle, and different things related to the equation. Suppose y is equals to 0.5 times sine pi times 10t plus 1/4 times x. Find first time period, second wavelength, third direction of traveling, velocity of wave, phase difference for part difference of 2 meter, these entire thing will be asked from this just single one question.
So for
Yes,
question number 3, for how many marks will it be?
it will be about 5 marks.
Okay.
Any doubt related to this last part in any of the calculation?
No, sir.
Mazia,
So I have a doubt, sir. If they say that x is in centimeter and they give in question 2 meter, like the point, then what should we do? Any conversion or something, sir?
all the calculations should be in same unit. That is, it will be better to convert the whole term to be in SI unit. Suppose if equation is given on rest of the whole term is in centimeter. So how will you calculate for part difference, phase difference? So it will be better to convert whole term in meter first and then apply the formula. Okay.
Okay.
Next question will be related to this part. to define beats and they will ask you to derive expression for it. And next also, they will give you some equation related to this part. Let me give you, suppose y equals to 0.02 times sine 500 pi times t, and y2 we have 0.04 sine 506 pi t. Find number of beats per minute. Yusra, just tell me what was the formula to calculate beats frequency? Raza, how to calculate beats frequency?
Difference of frequency of two waves.
Good. So from this part, how to calculate frequency? So you will say coefficient of t will be omega. So we have omega 1 equals to 500 pi. You may write omega as 2 pi times f. So you get f1 from this part. And similarly, omega 2, we have 506 pi. So you may write it as 2 pi f2. So you'll get f2. On taking difference of these two frequency, you'll get beats frequency, that is number of beats per second. But in this part, we have to calculate number of beats per minute. So how to define it? F1 we have 500 by 2, that is 250 hertz. And F2 we have 506, so it will be 253 hertz. So beats frequency, difference of frequency of two wave, so it will be 3 beats per second. We have to convert this part per minute. So 1 minute is equals to 60 seconds. So 1 second will be 1 by 60 of a minute. Just put it in the place of second. So you'll get 3 beats divided by 1 by 60 minutes. So the 60 will move to numerator. So you'll get 180 beats per minute. Gautam, is it clear?
Yes, sir. Clear.
Minashi, in it out?
No, sir.
There was a question in assignment. What will be the condition to obtain beat? I define you. If you have two different waves, one of the wave, this one. So 1 complete oscillation, 2 complete oscillation, 3 complete oscillation, 4 complete oscillation. So you'll say its frequency is 4 hertz. Another wave, which must be originating from the same point, like this. 1 complete, 2 complete, 3, 4, 5, 6, and 7. In both these two waves, we have same initial point, this one, and same initial point for this one. If you draw projection to this part. And this part. You will say both are starting from same point. So we can say they must be in phase, or simply phase difference between these two parts is 0. Is it clear?
Yes, sir.
So first property will be it should have same phase. Next, in beat, on superimposing these two waves having different frequency. So frequency should be different. And third, on overlapping over one another, it will create a loud sound and faint sound. To get minimum faint, that is difference of amplitude of these two waves to be minimum. So it should be 0. To get 0 minimum faint, the amplitude of these two waves should be equal to each other. So third property should be equal amplitude.
But I did not get the last property, sir. Explain.
Suppose in this part, we have amplitude from this point to this point. And in this part, amplitude from this point to this point. So if you have different amplitude, so on superimposing, it will create wave like this. So this part, that is loud sound, will be sum of amplitude of these two waves. Let's say this is A1 and this is A2. And this part, that is faint sound, will be difference of amplitude of these two waves. So to get this particular faint sound to be minimum, it should be equals to 0. Is it clear?
Yes.
So it will be better to get minimum faint sound, amplitude of each wave should be equal to each other. So these are main 3 minimum criteria to produce B. It may or it may not be, but these two should be necessary in B. Yusra, any doubt?
No doubt, sir.
Okay. So this is all about this entire wave. You'll be asked only these different questions related to this part. Next, let's move on to oscillation. That is simple harmonic motion. Suppose if you'll be asked to define which of the equation is SHM and which are not SHM, which are periodic, which are non-periodic. So how will you define? First, if function is trigonometric, then it will be always periodic. If you have function in trigonometric, so it will be always periodic. But if this trigonometric function is sine or cos with linear power, with linear exponent, then it will be SHM. Otherwise, it will be periodic, but not SHM. Is it clear?
Yes, sir.
Yes, sir.
Next, rest of the whole different function like log function, exponential function, there will be non-periodic and non-SHM. Suppose if you have y is equals to log of omega t, y is equals to exponential omega t. So how to check whether these functions are SHM or not? Just differentiate it twice to get acceleration. And if acceleration proportional to minus of displacement, then it will be necessarily SHM.
Sir, even other trigonometric values can also be linear, right? Like tan and all.
What, Gautam?
Sir, even tan can be linear function, right?
It may or it may not be. But in case of SHM, only we take sine and cos. Why? In case of sine and cos, its minimum and maximum value should be fixed. That is -1 and +1. And in case of SHM, we have fixed amplitude. That is from -a to maximum +A. But rest the whole trigonometric function, their minimum and maximum value should be -infinity to +infinity. So we can't define amplitude of an SHM to be -infinity to +infinity. That's why only linear exponent of sine and cos will be treated as SHM. Is it clear?
Yes, sir, clear.
Now you will be asked further. Suppose you have superposition of two different SHM. Let's say y is equals to sine of omega t, sine of 2 omega t. Will it be SHM or not? So just check frequency of these two parts. We have angular frequency omega, but in this part 2 omega. They are different, so it can't be SHM. On superposition of 2 SHM, I had defined you y1 is equals to a times of sine omega t and y2 is equals to b times of sine omega t plus phi. In this part, I had taken omega and omega same in both these two parts. That's why the resultant was a times sine omega t plus delta. So you will say superposition of two SHM having same frequency will be SHM. Otherwise, different frequency on superimposing will lead to periodic function, but not SHM. Is it clear?
Yes, sir.
Raza, is it clear?
Yes, sir.
So it will be periodic, but not SHM. So this is all about to define SHM or not. Next, related to this point, there was a question to derive differential form of SHM. Yusra, how to calculate this part? Differential form of SHM. Minashi, how to calculate differential form of SHM?
A sine omega plus.
First, we take normal displacement equation as y and differentiate it twice. So on differentiating, you will get velocity dy dt is equals to omega times of a cos omega t. On further differentiating this part, you will get minus of omega square a sine of omega t. This is nothing but y So we may write double derivative of displacement with respect to time plus omega square y is equals to 0. This is differential form of SHM. Mazia, any doubt?
No, sir. Sir, can you
Let me
please show the previous slide? One.
this part.
Yes, sir. Done.
If particle at t is equals to 0 is at a by 2. Right, equation of SHM and define its phase. In this part, we have at t is equals to 0, particle is at this point. So I define in SHM at t is equals to 0, its projection will define you nothing but, or its inclination will define you nothing but initial phase. So you may write general equation y is equals to a times sine omega t plus phi. Now put this value. We have t is equals to 0. So this entire term will be 0. We have y, which is equals to a by 2, which is equals to a and sine of just phi. This a part and this a part will get cancelled out. So you're left with 1 by 2 in left hand side. And right hand side, we have sine of phi is equals to 1 by 2. So the value of sine for which it is 1 by 2 will be 30 degree or pi by 6. Now put this in the above part, we'll get y is equals to a times sine omega t plus pi by 6. Gautam, is it clear?
Yes, sir. Great.
Raza, any doubt?
No, sir.
Okay,
Sir,
yes.
in the last class we had written beat frequency will difference in frequency of two waves. So for that the derivation is there, right? I think I did not get the last step of the derivation.
Okay. Suppose we have y1 is equals to a times of sine omega 1 into t. You may write omega 1 as 2 pi f. So it will be sine 2 pi f1 times t. Again, y2 is equals to a times sine omega 2 into t. That is a times of sine 2 pi f2 into t. So on adding, y will be equals to y1 plus y2. Take out a as common. So you're left with sine 2 pi f1 t plus sine 2 pi f2 into t. Now in this part, we have this term and this term, two different angles. So according to identity, sine of C plus sine of D is equals to 2 times sine C plus D by 2 cos c minus d by 2. So using this part, you may write y is equals to a 2 times sine c plus d, that is 2 pi f1 plus 2 pi f2 divided by 2. Next, cos 2 pi f1, 2 pi f2 by 2. So on solving, you will get 2 times of a sine. Take out 2 pi as common. So you're left with pi f1 plus f2 times t. And second part, cos f1 minus f2 times t. So in this part, we have two different frequency. First one is sum of frequency, and the second one is difference of frequency. So on superimposing two different waves, the expression was like this. One of the wave is like this, and the other was this one. So in this part, we have two different wave oscillating. So the outermost term will be nothing but f1 minus f2, and the inner part will be f1 plus f2. So which one will define you about beat, outermost or innermost?
Outermost.
That's why beat frequency is difference of frequency of two wave. Is it clear?
Yes, sir. So in beat, there are essentially two waves.
Yeah.
One inside and one outside.
Now next is there will be question on the basis of velocity and acceleration. So as we have displacement, Yusra, just tell me phase difference between displacement and velocity. If a particle is in SHM, so what would be the phase difference between displacement and velocity? I define, we suppose this is displacement, velocity, and acceleration. Minashi, just tell me phase difference between velocity and acceleration. Yes. Phase difference between these two parts will be pi by 2. These pi by 2, and in between these, it will be pi. Is it clear?
Yes, sir.
Next, for velocity of particle, you may write velocity is equals to omega times a cos omega t, that is time dependent function, or you may write omega times root under a square minus y square in terms of displacement. So using this, you may calculate different result according to the given part. Now from this part, you may be asked to define shape of curve between velocity and displacement. If you simplify this part, so on squaring, you will get v omega square a square minus y square If you expand it, you will get omega square a square minus omega square y square is equals to v square. Move this omega square y square to the left side. So omega square plus omega square y square is equals to omega square a square. Raza, is it clear up to this part?
Yes, sir.
Now we have to take this particular right side part, omega square a square, to be 1. So divide this entire segment by this one. So this part and this part will get cancelled out. So you're left with v square divided by omega times of a plus y square divided by a square is equals to 1. Do you know about this particular equation? What will be the shape of this part?
So v square by omega square by a square. Eh? Why would the squares go?
It's my mistake. Okay, so what will be the shape of this particular curve? Krishna,
So hyperbola.
elliptical path.
Oh yes, sir.
So it will be like this. So just remember, velocity and displacement graph will be elliptical in shape. This is displacement and this is velocity. And similarly, acceleration and displacement will be straight line. As acceleration is equals to omega square a times sine of omega t. You may write it as minus of omega square y is equals to a. So a is directly proportional to y with some negative slope, this one. So if you plot graph of this part, this will be a versus y, and slope of this particular part will define you omega square. So just remember these two relations and curve related to these different relations. Gautam, is it clear?
Yes, sir.
In case of energy or energy of Shm,
Sir, can you see the previous slide once more? So tan theta is equal to minus omega square, right?
in this part I have taken theta to be in clockwise direction with negative y-axis. That's why minus and minus become plus. But in general, you have to take theta from this part to this part. So it will be 180 minus theta, and tan of 180 minus theta will be minus of tan theta. That's why this minus and this minus will get cancelled out.
Okay.
Done? This is elliptical path. And this is straight line. You'll get the same result in case of momentum and energy, elliptical path. Now, next term is related to energy on SHM.
So what did you tell about momentum and energy? I got cut, sir.
As we have for velocity and displacement, path is elliptical. Similarly, in case of momentum and energy, path will be elliptical. Okay.
Okay, so only that there's no proof.
Yes.
Only the statement, right?
Yeah. For energy, I define you two different types of two different part of energy. One is potential energy and the other is kinetic energy. So you'll be asked to derive total energy or expression of total energy and draw variation of kinetic energy and potential energy. So I define you potential energy. It was half ky squared. If you put y to be m times omega squared, and y is equals to a squared sine squared omega t. In case of kinetic energy, it will be half mv squared, and v we have omega squared a squared cos square omega t. Now to get total energy, just add them, kinetic energy and potential energy. It will be half m omega square a square common. You're left with sine square theta plus cos square theta. That is nothing but 1. So it will be half m omega square a square, and it will be constant. What is the graph related to these different terms? I define you. This will define your total energy. For potential energy, we have sine square omega t. It means at 0, sine will be 0. So at origin, it will be minimum. So graph related to this part will be like this. And in case of kinetic energy, it will be like this. This was total energy, this is potential energy, and this is kinetic energy. Total energy versus displacement. This is mean position. This is point of intersection, that is a by root 2. This is extreme position A. Krishna, what is the relation between frequency of oscillating potential energy and frequency of actual wave? Gautam?
Yes, sir.
What is the relation between frequency of oscillating amplitude and oscillating potential energy?
It will be twice, right?
Good. In case of potential energy and kinetic energy, it will be twice of that of displacement, velocity, and acceleration. But in case of total energy, frequency will be 0 and time period will be infinite. The last part of this chapter is to calculate time period, in which I define a combination of a spring, series combination, parallel combination, and one more part, that is simple pendulum. So you'll be asked to derive expression of simple pendulum, time period of simple pendulum, or you may be asked to derive series or parallel combination of spring. And nothing more from this part also. Okay, so any more doubt up to this part? Please ask if you have.
So the one you asked me, can you explain that? So I couldn't get that.
Which part?
So the one you asked me, so the question.
I've just told you in part of third part of this particular chapter, that is calculation of time period. There were two different topics. One was a spring mass system. So you'll be asked to derive series or parallel combination of spring. Like we have in series combination, 1 by k equivalent is equals to 1 by k1 plus 1 by k2. But in parallel combination, it would be k equivalent is equals to k1 plus k2. Just opposite of what you have calculated for resistance in class 10th, series and parallel combination of resistance. Krishna, is it clear?
Yes, sir.
Or should I derive it?
No, sir. I could.
Next, you'll be asked to derive expression of time period of simple pendulum. That is t is equals to 2 pi root under L by G. And that's it. You may be asked to define different term, which I had explained you in the last part of oscillation, that is damped oscillation and undamped oscillation. Those two different terms. You'll be just asked to define and nothing more. Gautam, any doubt?
No, sir.
Okay, so let's stop here for today. I'm giving you 3 different chapters, that is thermal property of matter, kinetic theory of gas, and thermodynamics. Just revise these 3 different chapters. I will explain you in next class. Okay?
Sir, which one?
Thermal property of matter, thermodynamics, and kinetic theory of gas.
Okay, sir.
Okay then.